The next step in the process of these trigonometric integrals are two special integrals. And then from these, we're going to expand the ideas. Up until now, we've talked about the integral, the antiderivative of sine of x. We've talked about the antiderivative of cosine of x. Those are basic forms. These are not. And so, what's going to happen is you're going to have larger integrals. I've said this over and over again, but it's going to happen. You'll have larger integrals. You'll do a procedure, and you will inherit from that 2, 3, maybe 4 smaller integrals that you need to be able to work. When you do that process, it might not even look like it. You might start something that doesn't even have trigonometry in it. But when you do our process, you will inherit from that an integral. It might be this integral that you inherit. And so this are very commonly the types of integrals that you inherit from the procedures that we'll be talking about this section and also the next section up. And so knowing how to do these is fundamental. These just need to be straightforward, well within your comfort zone. And the key to each of these is using the identities that I talked about in the previous video. So what we can do is we can use the identity. Remember that sine squared of x is equal to 1/2 1 minus cosine of 2x. I should have mentioned this earlier. Notice this integral, or sorry, this argument is 1/2 of this, or this is double that number. What if we had 4x here? Then this is 1/2 1 minus cosine. This would be 8x. So this expression is double this, or this argument is half of that. That's why it's called the half angle. And so if this is, and similarly, if we had cosine squared of, let's say, 7x, that's 1/2 1 plus cosine, double the number, 14x. And so it doesn't matter what this argument is, this expression is twice as large. In this particular case, this is the most basic structure. And so I'm going to use this identity, replace sine squared of x with 1/2 of that quantity. The 1/2 is a constant multiplier, or I can throw that out in front of the integral if you like. You can plug inside or outside, whichever is more convenient for your particular problem. And then this is 1 minus cosine 2x dx. And now that's a basic form because that's the power rule. That's a basic form because it's cosine. And notice we have the 1/a rule. That's why I reviewed that just in the previous video, because this 1/a rule is going to come into play here. And so we have 1/2 times the expression. The antiderivative of a constant is you reattach the variable, minus the antiderivative of cosine of something is sine of the something. But we have the 1/a rule, and we're out. So this will happen over and over and over again. So just make the substitution, use the 1/a rule. If this is 2x, then we have a different 1/a to worry about. All right, so this is done in an exactly similar fashion, except now with cosine, remember it says positive. This is 1 plus cosine of 2x. And then the antiderivative, reattach the variable. The antiderivative of cosine of something is sine of the something. But I need 1/a, and we're out. And so those two special integrals will arise repeatedly, and being very comfortable with this procedure, that just needs to be like second nature to you, because they arise, not every problem, but often enough that you need to be really familiar with those. And so when we get to these larger integrals, we need to be able to say, okay, that's cosine squared. You can do that. You can finish that out because you know these basic identities. So those two special integrals are going to come into play very often in the work we're going to be encountering.